Okay guys, I'm back with the last video from 2.8, still using Descartes' rule of signs, and then we'll do some examples actually using Descartes' rule of signs. Okay, so let's finish doing some of these, so you got a few more to try. I'm gonna not write out the negative positive, I'm just gonna do it while I go. If I'm looking at the positive ones, it goes from negative to positive, so that would be 1. Positive, positive, nope. Positive, negative, yep, that's 2. And negative to positive, that's 3. So for positive, real zeros, I could have 3 or 1. Now, I put negative x in. I'm going to rewrite it with negative x. So you can see this would still be negative 3x to the 4th, but this would change to negative 12x cubed. This would stay 5x squared. This would change to plus x, and it would stay plus 18. So negative to negative is not 1. Negative to positive, there's 1. Positive to positive, no. Positive to positive, no. So for negative real zeros, there's 1. So doing that, I have 3 or 1 positive real zeros, and I have 1 possible negative real zero. Okay, for number 6, I'm going from negative to positive, so that's 1. So for positive real zeros, I have 1. And then f of negative x changes that. Nope, doesn't. It keeps it negative 27, x to the 4th, but changes to negative 25x. So I don't have any sign change. So for, negative real zeros, there's none. Okay, so 1 or 0. Okay, over here, that's positive to positive, nope. Positive to positive, nope. Positive negative 1, yes. Negative to positive 1, yes. There's 2, and positive negative 3. So for positive real zeros, there's 3 or 1. Okay, for negative, I'll put in negative x, and I would get negative 4x to the 5th plus 2x to the 4th minus 7x cubed minus x squared minus 5x minus 10. So checking, it goes minus to plus, that would be 1, plus to minus, that would be 2, and then minus, 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 minus. So for negative real zeros, it's 2 or 0. So positive, it's 3 or 1, and negative, it's 2 or 0. So we're getting good at this. I think you're okay. Let's move on to actually using it. So we're going to create a list of all possible rational zeros, then find them. So we're going to use Descartes' rule of signs to help us eliminate some of the P over Q's. So if you look at this first guy, can't factor by grouping or anything, so we're going to have to use P over Q. So let's start with P is equal to 8 and Q equals 1. So that's nice. Q equals 1, so I can just do what 8 would be. So my P over Q would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So that's 8 things I would have to try. But if I try to see if Descartes' rule of signs helps me, let's see what it gives me. So I go from negative, positive to positive, positive to positive, positive to negative. There's 1, and negative to negative. So I have 1. Okay, so there's 1 positive real zero. Okay, well, wait a minute. That means I can try positives, and I know one of these has to work. 1 or 2 or 4 or 8 have to work. So I'm going to start with my standard 1 and positive 1 and see if that works. So it would be synthetic division 1, 6, 7, negative 6, negative 8. Bring down the 1, I get 1 to 1. So that would be 1, so 7, 7. I'm doing something wrong, aren't I? Nope, 14. That's 14 here, which would be negative 8 here. Nope, positive 8, sorry. And put a positive 8 there, and look, sure enough, that worked. So guess what? It eliminates positive 2, positive 4, and positive 8. They cannot be, because there's only one positive, and I already found it. It was 1. So I have eliminated those, and so now, and I've used positive 1, so I'm left with choices of negative 1, negative 2, negative 4, and negative 8. So if I go to my f of negative x to see how many negative real zeros there are, that would stay x to the 4th, but it would change to minus 6x cubed plus 7x squared plus 6x minus 8. So I would have positive to negative 1, negative to positive 2, positive, positive, but positive, negative 3. So there are, for negative real zeros, there's 3 or 1. So out of 4, what if there's 3? It's a pretty good choice, right? We don't know. There could be just one of these works. So let's try my favorite one again, only this time let's try negative 1. Okay, so negative 1, make it neat. Negative 1. Okay, so we have, let's use our depressed polynomial. Okay, let's not go use the longer one because we know this has to go in it too. 1, 7, 14, 8. Bring down the 1, that would be negative 1, 6, negative 6, 8, negative 8, 0. Sure enough, negative 1 is one of my guys too, is one of the zeros too. And that reduces the polynomial to, depressed polynomial to x squared plus 6x plus 8. And hey, that factors to x plus 2, x plus 4. So I had x plus 1 and x minus 1 that worked also. So those are my linear factors. So x is equal to negative 4, negative 2, or plus or minus 1. And that's how you use Descartes' rule of signs. It helped me pick which P or Q to use. All right, so let's look at the next guy, number 10. Okay, so let's see, nothing looks good to factor out or anything, so I'm going to have to use P over Q. So P is equal to 4, and Q is equal to 2. So this is 1, 2, and 4, and this is 1 and 2. So possible P over Q are plus or minus 1, plus or minus 1/2, plus or minus 2, and plus or minus, that's 2 over 1, and 2 over 2 is still 1. Wow, you can't read that writing. Doesn't look good. So it was plus or minus 2, and then 4 over 1, so plus or minus 4, and 4 over 2 is 2. So those are the only ones. Plus or minus 1, plus or minus 1/2, plus or minus 2, and plus or minus 4. Now, let's do our P over Q to help our P over Q, our Descartes' rule of signs to see if we can see how many positive and negative there are. There's 1, no, positive to positive, none, positive to positive, nope, positive to positive, nope, positive. Okay, so there are 0 positive real roots, so I am not going to check any of the positive ones because I found out there aren't any. So I'm going to go to negative 1 first. Hopefully that'll work. 2, 15, 31, 20, and 4. So that would be 2, negative 2, 13, negative 13. Let's see. Take away 31. Gosh, I can't do that in my head. I'm getting tired. That would be 2, 8, 18. So 18, and that would be negative 18, and that would be 2. Nope, negative 1 doesn't work. So I tried negative 1. I know 1 doesn't work. I know negative 1 doesn't work now. I could go to 1/2, but I'm going to try to stay away from fractions. Let me try 2, but not positive 2 because I already know there isn't one. I'm going to try negative 2. So again, 2, 15, 31, 20, and 4. Okay, so that's 2, negative 4, that would be 11. Then that would be negative 22, and that would be 9. So negative 18, giving me 2, and negative 2 times 2 is negative 4. So yay, there's 1. Okay, so I have x plus 2 being one of my linear terms, and here's my depressed polynomial. So I can try, I'll try 4, negative 4 with this. So I'm going to even just keep it, watch how I can kind of just keep it using that line. So 2, that'd be negative 8, that'd be 3, negative 12, negative 3, positive 12. So 4 did not work. Shoot. I'm going to do a magic thing and erase. You guys can't do that. You have to use paper. Okay. So I'm going to do negative 1/2 now because that's the only other one. So, all right. Draw the line. 2. And this would be negative 1/2 times 2, which would be negative 1. And that would be 10. And 10 times negative 1/2 would be negative 5, which would give me positive 4. 4 times negative 1/2 would be negative 2. Remember, we're not using this one because this was the depressed polynomial, right? And that gives me 0. So yay, negative 1/2. So I have x plus 1/2 being a linear term. And then my depressed polynomial is 2x squared plus 10x plus 4. And that is not going to factor. So let's divide everything by 2. We'll set that equal to 0. Let's see, divide by 2. So 2, let's see, x squared plus 5x plus 2. We're going to factor out at 2. Right, 2, and that would be x squared plus 5x plus 2. And then I'm going to use the quadratic formula. So opposite of b, negative 5 plus or minus the square root of b squared, 25 minus 4 times a, which is 1, times c, which is 2, all over 2a. So 2a would be 2 times 1, so 2. So negative 5 plus or minus the square root of 25 minus 8. It's 25 minus 8. 17? Gosh, I should have known that. All right. 17 over 2. And there's nothing much I can do more than that. That's it. So, wait, let me get some more room over here and write out what the answer would be. So the answer would be negative 5 plus or minus the square root of 17 all over 2. And then what did we get? What were the other terms we got? Negative 2 and negative 1/2. So there's x. Yay! Okay, that was 2-8. All right, so stay tuned for 2-9 videos.